Okay, so we're gonna look at this trig addition practice. And just to remind you, okay, if this is an expanded form, your job is to compress it back down. So the one that you guys seem to be having the most trouble with is problem number 3. So I'm gonna take a look at it first. Okay, this is the expanded form of, there's a minus here, of tangent alpha minus beta. Well, 75 is alpha and 30 is beta. So this is actually just like saying tangent of 75 minus 30, which would be tangent of 45 degrees. And then you can look at your unit circle. If your answer to numbers 1, 2, and 3 are on the unit circle, you can take it one step farther. Okay, here's 45. The tangent value of 45 is 1. So the answer then would be 1. Okay. Now the next one, number 4, is the one I want to address also. Okay, for problem 4, you want to prove. With the proofs, okay, you look at both sides and just decide which side can be expanded. Always one side can be expanded, right? You can't do anything with a negative sign. There's nothing to do with that. So if you take a look at this side though, here is an addition of cosine that can be expanded out, right? So cosine it's a plus, so you gotta remember that you change the sign. So we actually are gonna expand, I'm gonna start way over here because it takes a little room. We have cosine x, cosine pi over 2, change the sign, sine x, sine pi over 2. Okay, these are the same things. This right here is just this written out, equals negative sine of x. My goal is to get them to look exactly, each side to look exactly the same, right? So I'm going to take a look at the left side and see what I can simplify. Right? Well, there's only 2 values here, this one and this one. So use your unit circle, find cosine at pi over 2. Here's pi over 2. Okay, cosine then would be 0. So this value right here is actually 0. Now go to, so 0 times cosine is just 0, it's gone. Minus, now find sine at pi over 2. So here's pi over 2, sine at pi over 2 is 1. So this value is 1. So you actually have sine of x times 1 equals the other side. Okay? Now if this is gone, we don't have to worry about nothing. And this is a negative times here. So this and this side actually match. So you have negative sine of x equaling negative sine of x. So your proof is this. Now guys, remember it's a proof, so you have to be sure that they match. In other words, you can't just write this answer. To get credit for your proof, you have to write this line as well. Okay, now, the next part I want to talk about is problems 5 through 9. On 5 through 9, okay, they are all written in compressed form, so your job is to expand them. 5, 6, 7, and 8 are all sine and cosine. The only one that's the newer one is number 9. Now guys, when we're expanding and we're using tangent, what did I tell you to avoid to make the problem easier? Don't remember? Thank you. Don't use any of the values that are root 3 over 3 of tangents because it makes the problem a lot harder. Okay, you'll get the right answer, but you have to do more work. So I'm going to try to come up with 165. I want to try to do it without using 30, 150, 210, and 320. All the ones that have a tangent of root 3 over 3. Do y'all see that? You'll be able to do it the other way, it's just harder. Now when you're using sine and cosine, you can use anything on the unit circle. But when you're doing tangent, this one gets a star, avoid tangents of root 3 over 3. So can anybody come up with 165 that's gonna avoid the numbers you're not allowed to use? Okay, that'll work great. So use tangent of 120 plus 45 here, and then expand that. Okay? Now go to the back. There's really only one thing I want to address on the back. Will you please read the directions for number 10? Read the directions for number 10. What do you notice that's different about number 10? Okay, that's true. Yeah, two different things. Okay, first of all, there's a secant here. Okay, we haven't talked about that, but we know. Let's talk about reciprocal functions again. The reciprocal function of secant is cosine. The reciprocal function of cosecant is sine. And then cotangent is tangent. So instead of secant here, I just look and say, okay, secant is the same as cosine. So I'm going to say, all right, cosine of beta is, and I flip it, -7/25, and I'm going to use that instead. The other thing that's different is how it was written. And you just look at this in two ways. You can rewrite it or you can notice. Okay, alpha is between 0 and pi over 2. And then beta is between pi over 2 and pi. It's kind of like one of those overlapping circles. Okay, that'll help you see that. Or if you don't like that, you can rewrite it. 0, alpha, pi over 2. And then pi over 2, beta, pi. If you like it better that way. Either way is fine. Right, I think the rest of the problems you should be okay with. So go ahead and finish them.